All right. Hello, calculus class. All right, so trapezoid rule. You're going to see, what's the reason for this? Why would we need this at this point? We've been going and working, and we've been doing all kinds of integrals. And what is the trapezoid rule, and why do we need it? Okay, so here we go. Integrate from 0 to 2 squared x squared plus 1. Well, in the form that it's in right now, we don't have a rule for this, okay? It cannot be, it is not integrable. Notice we cannot use power rule because we would need at least an x out here. We would need to make a 2x. So we can't do this one by hand. Now you do understand that 0 to 2 means that we need to find net area. So now we got to go back to how we found area originally. We used to use rectangles. If I look at the graph of this and I plot a couple of points, if I plug in 0, it's got the output 1. And if I plug a 2, it's got the output square root of 5, and square root of 5 is going to be about here, a little bit bigger than 2. And so you're going to see that this graph does something like this. So we're trying to find this net area, okay? If we wanted to guess, we could easily guess. We can see that this is a rectangle here that has an area of 2 by 1 rectangle, and then we can see that this is a 2 by about 2.4-ish, and like half of a triangle. So if we did 1/2 base, or kind of, if we said our base here is 2, our height is, so from here is 1, that's 2.4-ish. So this is about 1.4, so you can say that this area is about 1.4. So something bigger, around 3.4, somewhere in there, making a guesstimate, okay? Not very precise what I'm doing. I'm just doing stuff in my head real quick. So we've got to find a better way to figure out what this area is rather than we trying to use geometry, because this is not a triangle. All right. So in the past, we put rectangles. Well, what I'm going to show you now is what's better than a rectangle is a trapezoid. Okay. So here's what we're going to do. We're going to put 4 trapezoids. So I'm going to do n is 4, and we're going to use trapezoids. Okay? All right. So if I'm going to put 4 trapezoids, the width of each of those trapezoids is going to be a half. And what's different now is, here's the base of the trapezoid. The left part of the trapezoid touches the curve, the right part of the trapezoid touches a curve, and then you connect like that. So notice that trapezoid fits pretty nicely. Okay, same thing here. Left part touches, right part touches, there's that. Okay, left and right, left and right. So you can see that those 4 trapezoids that I've drawn fit kind of closely to the graph. I mean, it's not perfect, but they fit pretty good. So the first question we want to answer, why do we need trapezoid rule? We need trapezoid rule to find net area of functions that are not integrable. So if you can't integrate them, okay, if we have trouble trying to integrate and we want to find the net area, this is another option. Okay, so now I've got to find the area of those 4 trapezoids. All right, well, let's remember what the area of a trapezoid is. So if I just draw a trapezoid here, that's perpendicular. So this is the trapezoid I'm drawing. These are my legs. This is the height of the trapezoid, so that's the perpendicular distance between the legs. So the area of a trapezoid just 1 is a plus b over 2 times h, okay? So what I'm going to do is I'm going to write out the area for each one of these using function notation. So for the first trapezoid, or here, area of the first one, it should be f of 0 plus f of a half over 2 times h. And h is this here, is in this case we would call it delta x, right? It's the width, okay? So that's the first one. All right, let me do it like this. This is area of the first one plus area of the second one is going to be f of a half plus f of 1 over 2 times delta x. Area of the third one, f of 1 plus f of 3 halves over 2 times delta x. And I'm running out of room, so we'll drop down below. The fourth one here, f of 3 halves. So this leg, that height's f of 3 halves plus f of 2 over 2. And again, the height of the trapezoid is this way, which is delta x. Okay, so I wrote it like this on purpose because what I want to do is I want us to make a formula that will give us the, do the net area for us, and then I can apply it to other problems, okay? So let's see what this, how this rule looks like it's shaping out to be. So we want to find the area. We're using trapezoids. All right, notice that each term has a delta x and a 2. And no matter what problem you work, you're always going to get delta x over 2. That can factor out. So there's that. Now what are we left with on the inside? So once I take those 2 out, we're left with f of 0 plus f of a half and f of a half. We're left with 2 of those. Plus f of 1, f of 1, 2 f of 1s. Plus f of 3 halves, f of 3 halves, 2 f of 3 halves. Plus f of 2, hopefully that fits into the picture there. Yes, okay. So notice, other than the very left leg and the very right leg, all the other legs are added up twice. Those heights are added up twice. So this here is a little quick little way that we can do the computation and get the answer without having to go to each individual trapezoid and find each individual area. So let's make a couple of substitutions now, okay? So what's delta x? Well, delta x is a half, okay? Delta x is still always b minus a over n. So it's 2 minus 0 over 4 trapezoids, it's a half. So we've got a half over 2, which will fix that. F of 0 is 1. Now, so I'm going to have to go at this point, I'm going to have to break down and use my calculator and put some decimals in place. So I'll grab the calculator real quick. So let's see. And if I just type in, I'm going to just type in on my calculator, I'm just going to type in the function, so square root of x squared plus 1 into my y equals, and then I can use my table feature. Go to the table and make sure that it allows me to type it in myself, which it does. Okay. So I'm going to type in, so let's see, f of 0 is 1, we got that, because square root of 0 plus 1, 1. 2 times f of a half, so plug in a 0.5, I'm going to round it to 3 decimals, 2 times 1.118. So if I plug a half into this function, the square root of x squared plus 1, I get 1.118. Plus 2 times, well, f of 1, that's going to be square root of 2. All right, plus 2 times f of 3 halves. So let's do a 3 halves, see what we get. I got 1.8028, about 1.8028, plus, then the last one is just the square root of 5, okay? Where did I get square root of 5 from? Again, plug 2 into my function, square root of 5. Okay, so 1/2 over 2 is a fourth. So now let's type all this in. So we'll do 0.25 and add everything up, and let's see if we get somewhere in the ballpark of 3 or 3.4 like we predicted. So 1 plus 2 times 1.118 plus 2 square root of 2 plus 2 times 1.8028 plus square root of 5, and we've got 1/4 times all of that is approximately 2.976. Okay. So we were guessing and we saw some answer around 3. All right. So that's how you use trapezoid rule. And we'll do another problem now and we'll kind of give you this formula. So just to see if we can do this on a different function. Okay. And let's do one where we can check the answer so that we got one that we know how to integrate. That way we can check and verify. So I'm going to keep my trapezoid rule up there. All right. So just to make sure we want to write out trapezoid rule. It's always going to be delta x divided by 2. It's always going to be f of a, whatever that left-hand part is, that coefficient is 1, plus 2 times f of a plus delta x, plus 2 times f of a plus 2 delta x, plus dot, 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 plus, so then the very end is f of b. So the f of a and the f of b have a coefficient of 1. Everything else, all the other legs should have a coefficient of 2. So let's do this one here, which we will do it with trapezoid rule, and then we'll do it exact. So 0 to pi of sine x. So if we look at this picture, 0 to pi of sine x, there you go. That's what we want to find the area of. I'm going to use n is 4 again. You may not have 4 trapezoids. Sometimes you could have 6 trapezoids, right? It depends on the problem that's assigned. All right, so we're going to work this. We're going to approximate area using trapezoid rule for n is 4, okay? So I want to go ahead and figure out where all of my units are going to be. So halfway in between here is pi over 4, okay? So that's pi over 4, 2 pi over 4s. This is 3 pi over 4 pi. So now I have all my increments. And again, just to draw it, if we want to look at what the picture is going to look like, that first picture is not even a trapezoid, right? It's a triangle. Trapezoid. Another trapezoid. Here's a triangle. Okay. All right. So let's set it up. What is my delta x? So my delta x is the width of the interval divided by the number of trapezoids, so it's pi over 4, and that makes sense, okay? So now if I'm going to do trapezoid rule, I'll fill everything in. It's going to be pi over 4 over 2. F of the far left is 0, plus 2 times f of pi over 4, plus 2 times f of pi over 2, plus 2 times f of 3 pi over 4, plus f of pi. Okay, again, you can use your, get out of the way, you can use your calculator for this. You need to make sure that you're in radian mode. So go to mode, make sure you're in radians. I can, since my function is sine of x, I think we can do these in our head also. So power over 4 divided by 2, we get power over 8. Sine of 0 is 0, okay? 2 times sine of power over 4, that's the sine of 45 degrees. Sine of 45 degrees is 1 over square root of 2, okay? You can do this on your calculator. You should also get 0.707. All right, plus 2 times f of power over 2, that's 1. Plus 2 times f of 3 power over 4, that's, again, 1 over square root of 2. You can see these 2 points here are at the same level, okay? Plus f of pi is 0, okay? All right, there's that. All right, so at this point, I'm gonna use my calculator to add all this up, multiply by pi over 8, and see what we get. And you guys can work along with me. So we've got pi over 8. So I'll put that in parentheses. And then times 0 plus and we've got the answer you should get is 1.896, okay, for this area here. Now you can see, just looking at the picture, it looks like it's a little bit of an underestimate, all right? So the other thing we can do is we can double check our work simply by actually integrating this, because sine x is integrable. Integral of sine is negative cosine, 0 to pi, negative cosine of pi minus negative cosine of 0 minus negative cosine of 0. So cosine of pi is negative 1, negative 1 is 1, plus cosine of 0 is 1, 1 plus 1 is 2, and there you go. And there's your trapezoid rule. So here you go, here you have this. I'll give you some to practice, and you can try that, and I will send you an assignment via email to do with trapezoid rule, and hopefully this helps you out a little bit and gets us one step closer to doing well on the AP exam. All right, take care.